Welcome to you all to this MOOCs online video course Theory of Yarn Structure. In the last class we started module 8 Tensile Mechanics of Yarn. We discussed about two situations of fibrous bundle. One was very trivial case where all fibers have identical stress strain behavior. Then what will be the bundle characteristics, tensile characteristics we discussed. Second case we talked about Hamburger's theory. That theory predicts the tensile behavior of a parallel fiber bundle consists of two different types of fibers. And then we talked about how Hamburger's theory can be applied to yarns. So, a simple note also we discussed. Now, we will start with Hamburger's theory numerical problems. The first numerical problems reads as follows. Suppose a series of cotton polyester blended fibrous bundles are prepared by mixing the cotton and polyester fibers in the following mass blends ratio 100 by 0. So, 100% polyester cotton fibers, 0% polyester fibers, 90 10, 80 20, 70 30, 60 40, 50 50, 40 60, 30 70, 20 80, 10 90, 0 100. 0 100 means 100% polyester fibers, 0% cotton fibers. The cotton fibers possess tenacity of 0.36 Newton per tex and breaking strain of 11%, but the polyester fibers possess tenacity of 0.41 Newton per tex and breaking strain of 46%. Also the polyester fibers show specific stress of 0.12 Newton per tex at a strain of 11%. Calculate the tenacity of the bundles. That means what are given to us is P1 by T1 is equal to 0.36 Newton per tex is given. Also P2 by T2 is equal to 0.41 Newton per tex given. A1 is equal to 11%, A2 is equal to 46%, and one more important value is given, that is equal to 0.12 Newton per tex. So, these items of information are given to us. We have to calculate bundle tenacity at different blend ratios. What is bundle tenacity? From Hamburger's theory, we learn that bundle tenacity is maximum of G1 P1 T1 plus G2 by T2 G2 P2 T2. So, we need to calculate this function for different blend ratios. So, let us first start. When G1 is 1, G2 0, 100% cotton fiber. So, we will substitute all these quantities here. This will be maximum of G1 is 1 into P1 by this 0.36 plus G2 is 0 into 0.12, G2 is 0 into 0.41. So, if we calculate, this will be 0.36 and this will be 0. So, out of these two what is maximum? 0.36. So, bundle tenacity will be 0.36 Newton per tex. Second, G1 is given say 90% cotton fibers, G2 10% polyester fibers. What will be the bundle tenacity? We use the same formula, maximum of G1 is 0.9 into P1 by T1 is 0.36 plus 0.1 into 0.12 comma the second value 0.1 into 0.41. What will be the maximum value? Maximum of this quantity, you will find it out, this will be equal to 0.336 and 0.041. So, what is the maximum of these two, 0.366 and 0.41? Of course, 336 Newton per tex, right. Then we proceed to third, G1 cotton fiber percentage is 80 and G2 20. What will be the bundle tenacity? We use the same formula here, maximum of G1 is 0.80 into 0.36 plus 0.2 into 0.12 comma 0.20 into 0.41. What will be the maximum? Zero 0.312 082. So, what is the maximum? 0.312 Newton per tex. So, at 80-20 blend ratio, the bundle tenacity will be 0.312 Newton per tex. So, gradually it is reducing. So, there will be one blend ratio at which the bundle tenacity will be minimum, then again it will increase. We have to see what is that blend ratio. Fourth, let us consider G1 is 0.70, G2 is 0.30. What will be bundle tenacity? Max 0.70 into 0.36 plus 0.30 into 0.12, 0.30 into 0.41. Zero 0.288, 0.123, 0.288 Newton per tex. So, at 70-30 blend ratio, the bundle tenacity will be equal to 0.288 Newton per tex. Then we consider the next one, 0.60, G2 is 0.40. So, the bundle tenacity will be 0.60 into 0.36 plus 0.40 into 0.12 comma 0.40 into 0.41. So, what will be these two values? These two values will be 0.264, 0.164. What is the maximum in between these two? Newton per tex. So, at 60-40 blend ratio, bundle tenacity will be 0.264 Newton per tex. Now, we come to the next one, 50-50. What will be the bundle density at 50-50 blend ratio? (0.50) into 0.36 plus 0.50 into 0.12 comma 0.50 into 0.41. What will be these two values? These two values will be 0.240, 0.205, maximum is 0.240 Newton per tex. So, when cotton and polyester fibers are mixed in equal proportions in terms of weight, then the bundle tenacity will be 0.24 Newton per tex. We continue for the other blends. G1 is equal to 0.40, G2 is equal to 0.60. At this blend ratio, what will be the bundle tenacity? Maximum of 0.40 into 0.36 plus 0.60 into 0.12 comma these two. So, what will be these two value? Max of 0.144, 0.246. Look at these values. Now, this value is higher than this value, 0.246 Newton per tex. So, the minimum bundle tenacity will be obtained when the polyester fiber percentage is in between 50 to 60%. Right. Now, we proceed further to obtain the other blend ratios. G1 is 0.30, Z2 is 0.70. What is the bundle tenacity? Max of 0.30 into 0.36 plus 0.70 into 0.12 comma 0.70 into 0.41. What will be these two values? These two values will be maximum of 0.192, 0.287, which will be equal to 0.287 Newton per tex. See again that increasing trend started. At 30-70 blend ratio, the bundle tenacity value will be 0.287 Newton per tex. Next blend ratio, G1 is 0.20 and Z2 is 0.80. So, at this blend ratio, bundle tenacity will be maximum of these two 0.20 into 0.36 plus 0.80 into 0.12, 0.80 into 0.41. These two maximum will be 0.168, 0.328, 0.328 Newton per Tex. Next blend ratio, G1 is 0.10, G2 is 0.90. At this blend ratio, will be maximum of these two 36 plus 0.90 into 0.12 comma 0.90 into 0.41. So, these two will be 0.144, 0.369, 0.369 Newton per Tex. The last one, 100% polyester fibers. When the bundle is prepared from 100% polyester fiber, will be equal to, very simple, that is basically P2 by T2, that is equal to 0.41 Newton per Tex. If we summarize the results, what we see is that G1, G2 and bundle tenacity in Newton per Tex, dimensionless. So, 1 0, 9 0.1, 0.8 0.2, 0.7 0.3, 0.6 0.4, 0.5 0.4, 0.3, 0.2, 0 point this, 0 1. So, this value is 0.41, this value will be 0.369, this value will be 0.328, then this value will be 0.287, this value will be 0.246, this value 40 60, afterwards this value will be 0.240, then this value will be 0.264, then this value 0.288, this value will be 0.312, then then this value will be 0.336, then this value will be 3 point this. So, these values we calculated. Now, what we see is that it is decreasing. Somewhere here, we see it is again started increasing. So, this value continuously decreasing, after this it is again started increasing. So, the critical blend ratio lies in between 50 to 60. So, the behavior schematically will be G 1 say 1 0 here and G 2 0 1 here, and this will be the bundle tenacity. So, it starts decreasing somewhere here, again it starts increasing. This is the critical blend ratio. This we obtain from this numerical example. Now, let us consider a second numerical example, very similar manner. Suppose a series of cotton polyester blended fibrous bundle are prepared by mixing cotton and polypropylene fibers in the following mass blend ratio 100 0, 90 10, 80 20, 70 30 and so on. The cotton fiber possesses a tenacity of 0.36 Newton per tex, breaking strain of 11%, but the polypropylene fiber possesses tenacity of 0.53 Newton per tex and breaking strain of 25%. Also, the polypropylene fiber shows specific stress of 0.30 Newton per tex at 11%. Calculate the tenacity of the bundles. So, how would we solve this problem? This problem we would solve in a similar manner. Bundle tenacity is equal to maximum of these two T2, right. Here this P1 by T1 is given as 0.36 Newton per tex, P2 by T2 is given as 0.53 Newton per tex, and your S2, all right, A1 is given as 11%, A2 is given as 25%. So, S2 A1 by T2 is given as 0.3 Newton per tex. Now, what we will see, let us consider this as capital A, this as capital B. We will show you the results of calculations. Now, G 1, then we will show you the value of Newton per tex, B Newton per tex, max of A and B, that is equal to this Newton per tex, right. So, 1, 0.9, 0.8, 0.7, 0.6, 0.5, 4, 3, 2, 1, 0. So, this value will be 360. What is the maximum? 36. 0.9 it will be 0.354 and 0.053. What is maximum? 354. 0.8 it will be 0.348 and this will be 0.106. What is the maximum? 348. At 7 it will be 0.342, this will be 0.159, what will be maximum? 342. At 0.6 it will be 0.336, this will be 0.212, what is maximum? 336. At 0.5 it will be 0.330, this will be 0.265, what is maximum? 330. At 0.4 this value will be 324 and this value will be 0.318, maximum is 324. At 0.3 this value will be 0.318, but this value will be 0.371, and what is maximum in between these two? 371. At 0.2 this value will be 312, this value will be 424, 424. At 0.1 this value will be 306, this value will be 477, this value will be 477, and at 0 this value will be 0.3, this value will be 0.53. So, this value will be 0.53. What we see here is it is continuously decreasing, but from here 0.324 to 0.371, then again it is increasing. So, the very similar behavior, it is initially decreasing, then it is increasing. So, this was problem number 2. We stop here. In the next class we will continue with this module.